It might sound like a medical horror story at first. Bacteria in the blood. The mere idea conjures images of sepsis, organ failure, and urgent for antibiotics. And in many cases, that's not far from the truth. Bacteremia, or the presence of bacteria in the bloodstream, can be life-threatening. But recent scientific discoveries are beginning to complicate the picture. As it turns out, not all bacteria in the blood are hostile invaders. Some may be long-term residents, possibly even beneficial molecular messengers, with surprising roles in shaping inflammation, vascular integrity, and aging itself. This isn't science fiction or speculative microbiome hype. It's a slowly emerging reality. While the bloodstream was long thought to be sterile in healthy individuals, newer sequencing technologies have uncovered trace amounts of bacterial DNA, cell fragments, and metabolites in the blood of people who show no signs of infection. This so-called blood microbiome may reflect a combination of microbial fragments translocated from the gut, oral cavity, or skin, as well as a tiny number of viable but non-pathogenic organisms. Their presence isn't always dangerous, but it can profoundly shape systemic health, depending on the balance. Let's begin with the dark side. Pathogenic bacteria, when they enter the bloodstream, either through gum disease, a leaky gut, skin wounds, or post-surgical infections, can unleash a cascade of inflammatory signals. Cell wall components like lipopolysaccharides, LPS, from gram-negative bacteria and lipoteichoic acid from gram-positive bacteria activate toll-like receptors, TLRs, on immune cells, kicking off a storm of cytokines, including TNF-alpha, IL-6, and IL-1-SET. This inflammation doesn't just cause acute sickness. Chronically elevated levels of these markers have been linked to vascular stiffening, atherosclerosis, insulin resistance, and accelerated biological aging. Indeed, metabolic endotoxemia, a condition where small amounts of LPS enter the bloodstream regularly from the gut, is now recognized as a contributor to type 2 diabetes, obesity, and even Alzheimer's disease. It's a form of molecular sabotage. The immune system is perpetually on alert, leading to low-grade chronic inflammation that subtly erodes tissue function and cellular resilience over time. In older adults, this inflammatory burden, also known as inflammaging, is often amplified, and one of the suspects may be increased gut permeability, allowing more microbial fragments into the bloodstream. But the story doesn't end with inflammation and decay. Some bacteria, or more precisely, the compounds they produce, may have the opposite effect. Certain microbial metabolites that reach the blood, like indole derivatives, short-chain fatty acids, SCFAs, or bile acid conjugates, can help quell inflammation, support vascular elasticity, and even activate gene pathways linked to longevity. For example, indole 3-propionic acid IPA, produced by gut bacteria from dietary tryptophan, has been shown to reduce oxidative stress, enhance intestinal barrier function, and protect against age-related cognitive decline. IPA travels through the bloodstream, acting on the pregnane X receptor, PXR, and aryl hydrocarbon receptor, AHR, helping modulate immune responses and inflammation. Rather than triggering a systemic alarm, these microbial molecules help fine-tune the body's inflammatory thermostat. Similarly, butyrate, a short-chain fatty acid generated by gut bacteria fermenting dietary fiber, doesn't just benefit colon cells. It circulates in the blood and acts as an HDAC, histone deacetylase, inhibitor, influencing gene expression patterns related to inflammation, metabolism, and even mitochondrial function. It's a microbial message delivered via blood, one that says, slow down aging, reduce damage, stay calm. Then there's the newly discovered case of Paracoccus sanguinis, a microbe isolated from human blood that seems to persist without triggering a classic immune response. Early studies suggest it may interact with endothelial cells, influence nitric oxide signaling, or even help regulate immune tolerance in ways we don't yet fully understand. If certain bacteria can persist peacefully in blood and contribute to vascular health, the implications for anti-aging therapies are staggering. It shifts the narrative from bacteria equals infection to something more nuanced, microbial presence as a regulatory influence. But this delicate dance depends on balance. When beneficial bacteria or their byproducts are overwhelmed by inflammatory triggers, poor diet, chronic stress, disrupted gut flora, or infections, the blood becomes a pro-aging river of inflammatory cues. When things go right, It may become a vessel for youth-preserving molecular signals, subtly shaping immune resilience, metabolic flexibility, and tissue repair. This new understanding opens the door to future interventions that are less about killing microbes and more about managing their messages. Imagine precision probiotics engineered not just to colonize the gut, but to produce specific blood-active metabolites that enhance mitochondrial health or dampen systemic inflammation. Or treatments that bind and neutralize pro-inflammatory microbial fragments in the blood without wiping out gut bacteria. Some researchers are even investigating plasma exchange or blood filtration techniques to remove circulating microbial byproducts in patients with advanced inflammatory diseases, essentially editing the microbial signature of the bloodstream. So yes, bacteria in the blood can kill, but they might also heal, guide, or preserve, depending on who they are, what they're carrying, and how your immune system interprets their signals. Aging, in this light, is not just about the passage of time, but about the ongoing conversation between microbes and molecules, inflammation and repair, danger and tolerance. The blood, far from being a sterile battlefield, may be better understood as a biochemical negotiation zone, one where the line between harm and rejuvenation runs straight through a microbial whisper.